Hi everyone, it's nice to see you again, and in this lecture I'm going to complete what we have started in the next lectures, which is solving the exercises of section 1.1, which is the functions and their graphs. So today we have function number 5, which is of t equal t for divided by, which is a rational function. Rational function consists of a constant, which I can consider as a polynomial in the denominator, and in the bottom there is a 3 minus t, which is a polynomial of degree 1. So to solve this equation, I will follow the instructions that we studied in the first three lectures, which is named concepts and the skills. To find the domain of the function, of a rational function, the domain of the rational function is just the real numbers that makes the function well defined. That means all the real numbers that cannot make the denominator 0. So I will tell that I will make the denominator equal 0, the bottom, so 3 minus t equals 0, and I want to find out which numbers is prohibited for me to choose, I mean. So I will move t to the other side, that will be 3 equal t. So the number that makes this function undefined is t equal 3. So I will tell that the domain of the function f equals to all the real line, x equal to the real line, except, and I'm going to say t here. Why? Because the independent variable is t, such that t doesn't equal 3. Because I don't want a t to be 3, that will make no result from this function. To find the range, as we studied, we need to change the expression. We need to change the formation of the function, and I want to write the function in the other form. So I'm going to write it y equal to 4 on a 3 minus t, and I need to change the formation. To change the formation, this term has a denominator 1, so I need to multiply y divided by multiplied by 3 minus 2, and 1 divided by 4, the result will be 4. I'm going to follow the distribution law. So 3y minus ty, or yt, doesn't matter, same thing, 4. I need to make t on the left, on the side, and the others on the other side. So I'm going to move t to that side. So that will be 3y, and I'm going to move 4 to this side to be minus 4, and that will be a plus ty. So I'm going to divide by y. So the result will be t equals to 3y minus 4 divided by y. So it's clear that the range of this function, the range of this new function, or the domain of the new function, which is t, equals to all y belongs to the real number, such that y doesn't equal 0, because the only number that make this new functions not defined is the number y equal to 0. So the conclusion right now is just that the range of the original function f, or the output, will be all the belongs to the real line, such that y cannot be 0. That means this function could produce all the real line except 0. It could not produce 0, and it's clear if you find, as a notation, as a hint, if you find that that the top of the rational function, or the denominator of a function, is a constant, there is no variable, so the constant cannot be 0, so the result of the function cannot contain a 0 as output of its output's value. Now we're going to to study the next function, which is g, capital G to t equals 2 divided by t minus 16. T squared. Should be t squared, yeah. 2. It's too easy to find the domain of this function, and I think it's not very hard to find the range as well. So to solve this equation, we need to put the same expressions. So I need to find which values that make the denominator 0. So t squared equal to 16. I'm going to apply the square root to this value, squared equal to 16. I will get the absolute value to t equals to 4, and then I'm going to open the absolute value to be t equal to plus minus 4 from now on in the next lectures. And as you maybe do, I'm going to move from this step to this step directly. So as soon as you get a variable with an even exponent equals to some constant, the result will be that variable with plus minus the appropriate value that it works with that exponent. So the numbers, the real numbers will be plus 4 and minus 4. So I would say the domain of the function capital G equal to all the real numbers. X equals x belongs to the real numbers except x. I'm not speaking about in terms of x. We have t here, so just I'm going to change it to t such that t doesn't equal a plus or minus 4. I just want to exclude two numbers, which is a plus 4 and minus 4, because these numbers can make a problem when I substitute it to the function. So the range, to find the range, I need to change the expression. I'm going to denote for this one by, let me denote it by, for example, g. Okay, so g equal to 2 t squared minus 16. I'm going to apply the usual steps to simplify this equation and write it in the other expression. So as we know that this g is written in terms of t, so I need to write t in terms of g. So I need to simplify this function and make it first linear, get rid of the rationality of it, and then I need to I need to isolate the terms that contains t in the side and the terms that don't contain t in the other side. So what I'm going to do now, I'm going to multiply g by t squared, g by t squared minus 16, and I'm going to multiply 2 by 1 and equal to 2. So g t squared minus g 16 equal to 2. I need to isolate 2 as I told you. So I'm going to move this expression to that side. So g t squared equal to plus g 16. Okay, and I'm going to divide by g. T squared equal to 2 plus g 16 and divided by g. Now I need to apply the square root. So the square root to t squared equal to the square root to the 2 plus g 16 on g. The result will be the square root to t equals to the 2 plus g 16 and g. So the result will be t equal to plus minus 2 plus g 16 on g. Okay. So after we apply the square root, we get the new expression, which is t equal to plus minus, I'm going to rewrite it again, 2 plus g 16 divided by g. So, and it's too easy to find the domain of the new function because I'm just going to write down that this is the new form. T equals to, let's say, of the g, in terms of g. So this is, when I write f, that doesn't mean this f means any of these f's. It's just a notation that t is written in terms of g. So now I'm going to find the domain to this function, and it's too clear that if we want to find the domain to a square root function, we need to construct or to restrict that. We need to g satisfy that the expression inside the square root must be greater than or equal 0. Okay, this is actually it's not easy problem. How? Because g cannot be 0. G cannot be 0. Okay, so I need this value to be greater than or equal 0, and g cannot be 0, just a restriction. So I'm going to divide, I'm going to multiply by g. So I have here two cases. Case 1. Case 1, g could be positive, because when I multiply the inequality by a positive number, the sign of a greater than or less than will be fixed. But if I multiply by a negative value, this relation will be changed. The greater than or equal will change to be less than, and vice versa. So I will assume now that g is just a positive number. So when it's positive, I'm going to multiply both sides by g. So 2 plus g, 16 on g multiplied by g, and 0 multiplied by g will be just 0. So 2 plus g, 2 plus g, 16 will be greater than or equal 0. So divided by, I'm going to move g16 to this side, and greater than or equal minus 2, and g will be divided by 16. The result will be g greater than, divide both sides by 16, the result will be minus 1 on 8. So this is the first result. This is case 1, the case when g is just positive. Case 2, when g is just a negative number. Okay, g is less than 0. Okay, it cannot be 0, so I'm going to take it less than 0. When I divide both sides, when I have 2 g16 divided by g, and I'm going to multiply both sides by g, if it was a negative, the result will be 2 plus g16 less than or equal 0. And I will get g16 less than or equal to minus 2, and I'm going to divide, so g will be less than or equal to minus 1. So now I completed the two cases. I need to construct the domain of the new function. To construct the domain of this function, of the new function, I need to put in consideration the two cases. Let me explain to you or get the result of the case 1. This is case 1, I didn't remember. Case 1 will be case 1. Case 1 just has one result. I will take the common, I have construction 1 and have construction 2. I will take the common elements in these two conditions. So I have the real line here. This is the 0, and this is minus 1 divided by 8. So condition 1, g is greater than 0, so 0 is not included. This is g greater than 0. The condition number 2 is g greater than or equal g greater than or equal minus 1 divided by 8. So this is condition 1 and this is condition 2. I will take the elements in common between these two between these two conditions. I will start from the first point on the right that they have common elements to the infinity. So that will be g greater than 0. So this is the result 1. This is the result of case 1. Okay, so the result will be here, the common elements between this condition and this condition, and the common, in case you don't see this writing in the bottom of the board, I will write it here, g greater than 0. This is the result of the case 1. I'm going to erase this board here and try to conclude the result from case 2. Case 2, we have this line, this is 0, and this is minus 1 divided by 8. Going to change. I'm going to erase this one too. So we can have plenty place. We can have more place so we can see what's going on here. And this is the 0, and this is minus 1 divided by 8. And case 2, we assumed, where's case 2? Anybody help me? This is case 2. The condition 1, g is less than 0. G is less than 0. So this is condition 1, which is g less than 0, because it cannot equal to 0 because I have g in the denominator. I can't put a 0. And the result that I got from it, g is just less than or equal, okay, g less than or equal minus 1 divided by 8. Now I'm going to take the common elements between these cases. This case is different than this case. The common elements here, all the elements that greater than g, but the common elements in here, all the elements that g less than, or elements, I'm going to write it here just to save a place, will be all the g less than or equal minus 8. So the domain, the kids got back from the school. The domain of the new function, which is, I'm going to call it t, the domain to the function t will be all the x or all the g belongs to R, and we have two constructions, we have two conditions. The conditions are from case 1, which is g, from case 2, let's let's start the minus part, or g greater than 0. So the range of the function, where is the main function? G, I erase it. The g equal to all the elements, all elements g belongs to R, such that g less than or equal minus 1 divided by 8, or g just greater than or equal 0. So in this lecture, I completed to you the solution of the first 6 equations or 6 questions in exercise 1.1, in exercise 1.1, and which is find the domain and the range of the functions. In the next lecture, I'm going to complete the other functions. See you guys and have a good day. Thank you.